Hi, my name is Ronald, and today we'll be talking about a microcontroller and simulation on a PC. We'll be using two major tools here, that's the compiler and a simulator. The compiler happens to be one from Micro E, that's the Micro C Pro for PIC microcontrollers, and then we'll be using the proteus simulator from Lab Center. With the simulator, we have two versions. We have the version 7 and version 8. Preferably, I use version 8 a lot. If you have the version 7, it'll still work with whatever you're going to do. The Micro C comes in two forms, the free version and the paid version. The free version offers up to a maximum of 2K source code, while the paid version allows for unlimited. So, let's start. We'll be looking at a simple blinking LED using a small controller as a PIC 16F628A. To start, we open our proteus simulator. It's either going to be on desktop like this, Windows 8, or if you're using a Windows 8 or Windows 7 like me, you might have it down here. So I open my proteus 8, and to start a new design, we click on the blue icon we have here, that's the schematic capture. This will give us a schematic sheet where we're going to place our components to run our simulation. There are various modes on the side here. This is the select mode, the component mode, the junction dot mode, the label mode, and the value, it continues. To know which mode, move your pointer close to it, and it's going to show you whatever mode you want to go into. But for us to place our components, for now, we're going to the component mode. Once in component mode, you press on the P. This gives you the option to pick devices, and Proteus has a very large database of parts. We're going to type the component we want to use as a PIC 16F628, and gives us the version 8. And you can see a 2KB, 224 byte data, 128 byte EEPROM. I have ports A and B, 1 CCP, 3 timers, and 1 USB ART. This is what we're going to use for our design. We double click on it, and we can see it displays in our devices list. The next component we're going to take is a resistor. We double click on it, and we say there. The next component we're going to take is the LED. We click on it. With this one, we don't see only one. We see various ones, and we're going to choose one. This one, which is highlighted here, is not animated. So when we run simulation, we will not see it glow. But since running simulation, when we see it glow, we'll go for the animated version. And we have blue, green, red, yellow. I prefer to use the yellow a lot, or red. But for this one, we're going to use red. So I double click on the red, and we go. For every microcontroller, we need to have a pulse generated, and this is done using a crystal. So I choose my crystal, I double click on it, and it goes there. From the data sheet of all crystals, they go with capacitors, and these are fixed capacitors. So I choose my capacitor, and we can see we have the fixed capacitor here. I double click on it, and we have it there. Once I'm done selecting all components I need, I click on OK, and my components are here in my part list. That's my device list. Sorry. So first, I take my microcontroller and I place it on my sheet. You can place it anywhere you want. I might prefer to place it in the center. So I place it in the center. Use your scroll wheel to zoom and zoom out if you want to zoom or zoom out. Use the pressing on the scroll wheel allow you to pan the sheet left, right, anywhere you want to place it. Click on it again, releases it. Okay. I prefer to see things in detail, so I do a lot of zooming and panning a lot. Sorry if that's what is a lot, but this is how I normally do my design to make sure I get close to the part and then I don't have to strain my eyes to select the tips of the pins. So we want the blinking LED to be on RA0. which you can see here. So I select my resistor, I select an LED, and we connect it. This needs to be connected to ground. To have ground, we go into our terminal mode and select ground. We connect it. 10K here is too high for this LED to turn on. For the value of the R1 here, the output at the pin 17 is 5 volts, and what voltage we need here is 2 volts. So for us to know the resistance here, is going to be 5 minus 2 divided by the resistance, divided by the current the LED is going to drain. This is going to give us 3 divided by 20 milliamps, that gives us 150 ohms. So double clicking on the part, it gives you the option to edit the component, and we'll put our resistance there, 150. This changes it from 10K to 150. Okay. For every microcontroller to run, especially with the PIC microcontrollers, we need to connect the M clear to high. For us not to drain all the battery or all the power, we normally pass it through a resistor, so we have little current being drawn by the M clear. So we prefer to use a 10K, and we go to a terminal mode, we select power. By default, this power is 5 volts, and this is going to reset the microcontroller anytime it's turned on. Once you don't do this, you can't reset it when it's turned on. You can have your own push button here to reset the system as and when you want, when system is in one mode. But for now, that is not part of it. Replace the crystal, which we intend to use, and for us to rotate, we use the plus or the minus on your number keypad on the keyboard. So I push that, and I place my component. The reason why I'm connecting it to RA7 and RA6 is you can see it's also inscripting OSC1 and OSC2. This means oscillator. So we connect it to the oscillator. For the oscillator to run properly, we need some capacitors. So I put one capacitor here, and I put my second capacitor there. We go back to the terminal mode, we choose ground, and we put the ground there. This will change the property to 8 megahertz, and this will change to 33 picofarad. So basically, these are the connections we need to have it done. But when we run this by pressing on the play button down here, this is going to generate an error telling us the PIC program property not specified. Real-time simulation failed to start. That means this chip will be a dead chip without a program. So we're going to write a program to it. To write our program, we're going to minimize this, and we'll open our micro C. It will take time to open depending on how fast the machine is. I happen to be using a Core 2, so my system is not that fast. This is a project I've already done, but we're not going to do this. So for us to start a new project, I'm going to close this project and close whatever I have here. But if it's a new installation, definitely you wouldn't see this. You only see the start page. To start a new project, we come to project, new project, we choose next, we give the name of the project, and we call this one blinking LED. You choose the folder in which you want your project to be saved in, and I want all my projects to be saved in my libraries, my document, and I have truth here. I click OK and have blinking LED. The device name, you choose the microcontroller you wish to write a program for, and we scroll through the list. We have a 16F628. I think we bypass that. 628A. Then we choose the device clocking. We choose next. Ignore that. We choose next. We choose next. We check on open edit project so we can do some changes to the configuration of the microcontroller when it's been built to. We click finished. Once this is done, it's going to open the edit project, and the oscillator should be on HS, high speed crystal oscillator on what we just done, which means we're going to use an external oscillator. The watchdog, I always prefer you turn it off. The power time, I always prefer you disable it. The MC killer VP, always enable it for us to use external reset. Once you disable it, you're going to use internal reset, which is one of the best if in case you want to use interrupt resets anytime the program is run mode. The brownout detect, you can enable or disable it depending on the power system design. The low voltage programming will be disabled, so everything by default here is okay. But if otherwise you're having something different, let's make sure you change it to the default we have here. Once you're done, you click OK, and we're going to write a program. Please note, the program you're writing is all in C. So if you don't have any C background, you still need to take some books or take some lessons in C, because I will not cover everything in C. Okay. So micro C has made things very, very simple for us. So we're going to write a program to do that. First of all, we need to do some initialization of the microcontroller, which if you've done microcontroller 101 already, you will know what we're talking about. So first, I'm going to initialize the ports, and to do that with the pick, we call this the trace. And trace A means for the A port, trace B means for the B port. So A, and I put equal to 2 times 0 is 0, means I want to send it as an output, and I can do trace B to as an output. Then I'm going to set all the ports as low. Sorry. Please, this is not case sensitive, so it doesn't matter, but I prefer to maintain my formatting to have this thing done anytime I'm reading through. Once this is done, we turn off the comparator with the CMCon 07. And please note, all the 0 times you see, these values are in hex. If you want them in binary, it's going to be 0B, then the binary value. All these are in hex. If you want them in binary, please, it's going to be 0B and in binary. Once this is done, I'm done initializing my ports, my microcontroller, and when I click on compile here, it compiles successfully. And when I come to my program, I right click, go to edit properties, and I choose my program, which is stored in libraries, documents, tools, blinking LED. I click OK. I change the crystal to 8 MHz because that's what it's running on, and I click OK. Once I click run, you can see it didn't give us the error we generated the first time, and this time I set all the pins to be low, and you can see they've all been set to blue. Blue means it's low, whilst red means it's high. So you can see this is off. So let's run the program that is going to make it blue. Okay, so how many times do we want it to blink? I want it to blink 10 times. So I define a variable to do some looping, and I call this one an integer II. So over here I can do a loop here for II is equal to 0 and II is less than, want it to loop 10 times, less than 10, II is incremental, we open up and we can do port A dot F0 is equal to 1, which is going to set it to high, right? We can copy that, and then we delay for for 1 second. Remember, this is an ms, so it's 1000 ms code 1 second, and we can paste this and change it to 0. And don't forget to delay for 100,000 ms. Let's format this properly and let's compile this. Once this is done, this is going to make our LED blink 10 times. Okay, let's try that. Program is already loaded. You can confirm that, and we can see you can reload it. We click OK, and we click Run, and we can see our LED starts blinking. And this is going to blink 10 times, and it's going to stop. So if you got these tutorials right, thank you for watching. I'll come out with another one for it to blink forever and to have some sequence done. Thank you. Bye bye.